All right, let's take a look at quadratic functions. Quadratic functions are functions that have the form ax squared plus bx plus c. We've seen quadratics already this semester. When it looks like this, we call this general form. We're going to see in a few minutes that we can take this, rearrange this, and we get a form that is a little bit more useful, and this is called standard form. And once we're in standard form, we can see this looks more like the transformation stuff that we saw a few sections ago. Now, when we're looking at the graph, we know that we're going to get a parabola when we graph a quadratic. So we're expecting a picture that looks something like this. Now, there's two features that we want to look at in this graph today. One is this point down here. Now, it's either going to be the bottommost portion of the graph, if the graph's facing up, or if this is upside down, it'll be the top point on the graph. This is called the vertex, and this is going to be the point we're going to call HK. Now, these letters, of course, match the ones up here. Also, a parabola is symmetric about what we call the line of symmetry. Can't spell. All right, the line of symmetry. Now, the line of symmetry, since this is a vertical line, it's always going to be the equation x equals, and since it goes through the x value of this vertex, it's always x is equal to h. So if we can take this from general form, put it in the standard form, we'll be able to look at this directly, see exactly what the vertex is, that bottom point. We'll be able to look at exactly, see what the line of symmetry is, and then it'll make this very easy to graph this parabola. All right, so the first thing we want to take a look at is how do we go from general form to standard form? Well, anytime you see that binomial squared in a formula, you know you're going to have to complete the square. So let's go over here and let me write us some steps for how to put this into standard form. Step 1, factor the lead coefficient out of all the variable terms. Step 2, inside the parentheses, add and subtract half the linear coefficients squared, just like we always do when we complete the square. Step 3, factor. Step 4, distribute the lead coefficient back in. And step 5, just one more step, all you're going to do is just simplify. All right, so let's see if we can do one of these real quick. So let's start out with something that is in plus 4x minus 5. So this would be in general form. So if we want to put this in the standard form, let's follow our steps. Step 1 says factor the lead coefficient out of the variable terms. Now, I only care about the ones that have the x's. We're basically going to ignore the constant until the very end. We're just going to throw that out over to the side. So I'm going to factor the 2 out here. So it's x squared plus 2x minus 5. Now, inside these parentheses, I use square brackets just for readability. Inside there, we're going to do our completing the square thing. We're going to add something squared and then take something squared away. Now, normally we add something squared to both sides, but since I really don't have two sides of this, we have to do it all on one side. So notice whatever I put into here, this is really just 0. So I'm not changing the value of this side, I'm just going to change how it looks. So we take half the linear coefficient and put it on the inside. Now those three terms, the first three terms will factor. and that factors to x plus 1 squared. And of course, that's just minus 1, like always. Once you've factored, go ahead and distribute the lead coefficient back in. So that's 2x plus 1 squared minus 2 minus 5. So x plus 1 squared minus 7. Now this is in standard form. So when it's in standard form, remember our standard form looks like this. Ax minus h squared plus k. Once it's in standard form, we should be able to look at this and see what the vertex is. Now, just like the circles that we did a couple sections ago, since the minus here is in the formula, it's the opposite of whatever we see in here. So the x value of the vertex is going to be -1, and k is just whatever number is sitting out there. So that's going to be -7. Now our line of symmetry is always x equals whatever the x value of the vertex is, so -1. Okay, so notice our completing the square skill isn't going away. We're going to use it again here. So once you complete the square, you get it in the standard form, you should just visually be able to look at it and see what the vertex is and what the line of symmetry is. All right, let me give you one of these to try, and then we'll move on to the next topic. All right, so let's say I gave you our function f of x is equal to 3x squared minus, I don't know, how about minus 12x minus 4. All right, hit pause, see if you can put this in the standard form and stay with the vertexes and the line of symmetry. All right, so if you're back, let's give this a shot. So step 1 says factor out the lead coefficient out of the variable terms, so it's minus 4x minus 4. Inside the parentheses, we're going to complete the square, so I'm going to add something squared and take that same thing away, minus 4. Inside the parentheses, we put half the linear coefficient. That now factors. That's going to factor to x minus 2 squared. Of course, that's minus. -2 squared is 4. Minus 4. Go ahead and distribute your lead coefficient back in. So that's 3x minus 2 squared minus 12 minus 4. So finally, we get this in the standard form, x minus 2 squared minus 16. Again, notice in this form, we can see what all of our shifts are. If you think about this, just shifts in a regular parabola. It shifted to the right 2, down 16, and the 3 out fronts are scalars. That's going to make it 3 times as skinny or more narrow. So by looking at our formula, the vertex here would be 2, -16. And our line of symmetry is x is equal to 2. All right, so very, very easy to graph this now, right? Because all we'd have to do is plot the vertex and a line of symmetry and then find one more point on the graph and we would actually be able to sketch this. So let's take a look at how to graph this very, very quickly. All right, get that out of here. All right, so let's say that I gave you y equals, let's go to the y notation, and let's just do x squared minus 6x plus 2. All right, again, let's see if we can put this into standard notation. So do me a favor, take a second, see if you can put this into standard notation, stay with the vertexes and the line of symmetry. Go. All right, if you're back, let's go ahead and put this in this standard form. Here are lead coefficients of 1, so technically you really don't have to do this, but just so we do the same thing every time, I'm going to go ahead and factor it out just so you can kind of see. Now, if you didn't want to factor out the 1 and you just completed the square, that's fine. So there's our 1. Again, x squared minus 6x plus parentheses squared minus parentheses squared plus 2. Inside our parentheses here, we put half the linear coefficient, so that gives me a -3. Those three pieces will factor. So that factors to x minus 3 squared, and minus negative 3 squared would be 9 plus 2. That's 1 x minus, I guess I could, let me just go ahead and distribute here. Distribute to 1, we get x minus 3 squared minus 9 plus 2. So y is equal to x minus 3 squared minus 7. So now this thing has a vertex 3, negative 7, and a line of symmetry of x is equal to 3. Okay, so how are we going to sketch a graph of this? Well, to graph a parabola, you need at least 3 points. Unfortunately, right now, all we have is 1 point. So if we go ahead and graph this point right here, hold on a second. All right, so if we graph our vertex, that's the point 3, negative 7, that's over here somewhere. And you think about it, we have a line of symmetry here. Now remember, symmetry means the same on both sides. So if I know a point on this side of the graph, that means I also know a point on this side of the graph, or vice versa. So do I know any points up there? Well, the easiest point to find for this is to find the y-intercept, because parabolas will always find the y-intercept. Remember, we always find y-intercepts by letting x be equal to 0. Now the good news is you can plug it into the standard form that we just did, or the general form that we started with. And by the way, general form is actually easier to do here, because if we plug x equals 0 into there, we get what? 0 squared minus 6 times 0 plus 2, or we just get y is equal to 2. So we have a point on this graph. X is 0, y is 2. So that's this point right here. Excuse me. Now, by symmetry, if you think about this line of symmetry, we did what? 1, 2, 3 steps that way. That means that if we come up here and go 1, 2, 3 steps that way, there has to also be a point. So you see we kind of got that as a, right? We didn't have to do any work for that one. Once we found the y-intercept, we had the point on the exact opposite side. Now, another easy, air quotes on easy here, point to find are the x-intercepts. How do we find x-intercepts? Well, you let y be equal to 0, and you could do it in either one of these equations and solve. But here, let's just go ahead and connect these dots, and you see we kind of get this nice parabola-like shape. All right, so being able to graph a parabola, it's very useful to be able to put it in the standard form so you can see your vertex line of symmetry. That gives you 1 point on the graph and a kind of mirror image line to do. The easiest other point to find would be the y-intercept, let x be equal to 0. Once you plot the y-intercept, go the exact same distance on the other side and get your free point. That gives you the 3 points that you need to graph a parabola, connect the points, and there you go. All right, so let's take a look at the next thing. Sometimes the only thing we're interested in a parabola or a quadratic is where the vertex is and what the vertex actually is. Now we could go through all this work here to find the vertex, but there's actually a shortcut to this. So let's take a look at this for just finding the vertex. All right, so let's see. Finding the vertex. All right, the formula for the vertex, if we're given this in general form, ax squared plus bx plus c. So if we start with this and we don't want to do the work to put it into standard form so we can just see what the vertex is, our vertex can be found, there's an e in there, by doing negative b over 2a and then taking that and plugging it into our function. Now remember here I called this y, but that's just the function that we're talking about. Let's try one of these. This is really just using a formula, very quick and easy. So let's say I gave you f of x is equal to, I don't know, 2x squared minus 8x plus 3. And I said find the vertex. All right, so all we need to do is figure out what negative b over 2a is. That'll be the x value of the vertex. Well, b is the coefficient in front of the x, so that's going to be negative 8 all over 2 times a. A is the leading coefficient, so 2 times 2. That's 8 over 4, or 2. So we found half of our vertex, that's the x value. And remember, anytime you have an x value and want to find a y value, all you need to do is plug it back into the original function. So f of 2 times 2 squared minus 8 times 2 plus 3. You can see, do a little arithmetic. 2 times 4 minus 16 plus 3. 8 minus 16 plus 3 is what, negative 5? Check my arithmetic there, make sure that that's right. So our vertex will be the point x was 2, y is negative 5. Now remember, since the vertex is either the highest spot or the lowest spot on the graph, it's very easy to find the maximum spot or the minimum spot on the graph, depending on which way the parabola is facing. All right, so from this, these ideas, you should be able to take a quadratic that's in general form, put it into standard form, state the vertex, the line of symmetry, be able to sketch it, and if you are just given a general form quadratic, you should be able just to find the vertex really quick.